I just wanted to make a short video to show you how you can use your model kits to build models that have double bonds. So in chapter 12 we're looking at compounds that have sites of unsaturation. So those get replaced, those hydrogens get replaced with a double bond or a triple bond or maybe some of both. So we're going to build models for 1,2-dichloroethene. And so the ENE here on the ending lets us know that this compound has a double bond. The F tells us that there's 2 carbons. And so if there's only 2 carbons, then obviously the double bond is in between them. And at sites 1 and 2, we have a chlorine group. So the models, building them will kind of help you see how the actual molecule behaves and why there are 2 forms of this compound. So what I have already here is a carbon center, and here I've attached a hydrogen and a chlorine. So we'll call this carbon number 1, and carbon number 2 also has the chlorine. So I've attached it here. And between these 2 carbons is a double bond. So in your kits, you have these flexible white bonds that you can use and show an actual double bond between the 2 carbons. Oh, my chlorine fell off. Okay, so what I've built now, we can see that there 2 carbons here are sharing more than just 2 electrons. They're sharing 4 electrons, and kind of gives rise to something that looks sort of flat. The molecule is not like a zigzag kind of thing that we've seen before. And if we look across the double bond, we see that the chlorines are on the same side of the double bond. And what's interesting to note in the model is that we can't rotate it like we can in an alkane molecule. So these 2 chlorines are fixed. It's a rigid structure, and we can't twist this around. So this gives rise to what we call the cis isomer. And so we would name it just like that, cis hyphen, and then we would continue on. 1,2 dichloroethene. Just to contrast that one, if we build another one, so here I have the same 2 carbons and I have my flexible bonds here, I'm going to build the other isomer, which is, potentially it can be chemically different, could have different properties, different boiling point. Chemically it might behave different. And again, this double bond system is rigid, so there's no rotating and getting these chlorines on the same side. In this molecule, the chlorines, so here's our double bond, they're on the opposite sides of that double bond. So this is a model for the other isomer, and we call this one the trans. 1,2-dichloroethene. All right, just another example, we can look at models here for 2-butene. So we know we have a double bond. We know there are 4 carbons involved, and this number here tells us the location of the double bond. The double bond is located at carbon number 2. So what I've done first is built for you just a butane molecule. All right, so what we know is that this single bond, which, we obviously could have rotation here, instead we have a site of unsaturation. So we have a double bond here. And that, of course, is going to give rise to some isomers. Your textbook will go into how you know whether you have cis or trans, and sometimes you don't. In this case, we do. All right, and I happen to have built, here's my double bond, and now I have a group here. This methyl group is on this side of the double bond. The other methyl group is on the other side of the double bond. So that's what we mean by sides. So this molecule that I've built here is the trans isomer. So it would be called trans 2-butene. And then, of course, it could also exist in the cis version. So again, I've got a butane. I'm going to replace that single bond with a double bond. And this time, I'm going to do it so that the methyl groups are on the same side of the double bond. All right, and so actually structurally these are quite different. These molecules would definitely have different properties, different boiling points, behave differently chemically. And this one would be called cis-2-butene.